Off we go. So we measure 29 dog weights, and we want to find a confidence interval for the actual mean weight of dogs based on this sample of 29. Hello, Kelly. And we're assuming we know the population standard deviation, which is unusual, but sometimes. Based on this, construct a confidence interval. So just make some notes. This would be our N, our sample size. This right here, they're telling us that's the mean weight of these 29 dogs. We'd call that X bar, our sample statistic. And then this right here is sigma. So that's the population standard deviation. And if we know sigma, right, we know sigma, then that means that we're going to use a normal distribution for this. And z-scores go with a normal distribution. Other alternative is a t distribution and t-scores. So let's sketch out our graph. Since this is a confidence interval, the sample mean goes in the middle. Unlike a hypothesis test, so we have 30 in the middle, and then 1, 2, 3 standard deviations on each side is the standard thing to do here. And then we just need to know, well, how far is a standard deviation? And the standard deviation here, that would be called sigma with a subscript X bar. So that's the for the distribution of means, and that's going to be that 7.5 over the square root of 29. So we need to make that calculation. And so I might as well start a spreadsheet to accumulate these numbers. And then we'll also whip out Statkey, because it'll draw a nice picture. All right, and this is the spreadsheet I've been using this week. Let's start a new page. Okay, so dogs. And we know, let's see, N is 29. We know the mean of the sample is 30. We know sigma, the population standard deviation, is, what was that, 7.5? Yep. And you could use one of those pre-built spreadsheets, but I like to, this helps me think about it. Let's see, I know the confidence level, that is 99%. And I want, let's see, we're going to also want alpha, and alpha over 2. Tail. So alpha, remember, is always equal to 1 minus the confidence level. And then we split that in half for the tails. Okay, and then I said I needed the standard error. And that's the standard deviation for the sample means. And that's always some population or sample standard deviation divided by the square root of the sample size. Let's see, I got a couple questions. Which pre-built spreadsheet should we use? Good question. I'll take a look at that in just a sec. Just get this calculated from a picture. All right, so about 1.4-ish is what that ends up being. Let's see, number 10 in the applications. The test statistic. Yeah, we talked about test statistics yesterday. I made a special video just about what test statistic means. It should be at the end of the playlist. All right, so let's go back to my picture, and then we'll take a look at which of those pre-built spreadsheets would be good to use here. Oops, there's my picture. So this count comes out to be approximately 1.4-ish. So 1 standard deviation to the right would be 31.4. One standard deviation to the left would be, what would that be, 28.6. And my, let's see, and the 99% confidence interval. So we need to figure out where that falls out here. So a 99% confidence interval is going to be pretty close to the third standard deviation. So that's going to be probably right around here for a 99% confidence interval. And then we just need to know what weights go here and here. And the central limit theorem says basically find the z-scores. So that's a negative z on that, positive z on that, 0 z is always in the middle. And a z-score just counts standard deviations. So like this 31.4 would be a z of 1, and this would be a z of negative 1 right there. To calculate the z-score that goes with this right here to get the margin of error, we would, on a spreadsheet, use the norm inverse. And the norm inverse needs the tail probability, 31.4. That is the mean plus 1 standard deviation, because I calculated the standard error of this distribution to be 1.4. So 30 plus 1.4, and then this 28.6 is 30 minus 1.4. So I'm just getting a feel for how the numbers are spread out for the sampling distribution, which is what we need to make a confidence interval. So let's see, what do we have in the tail? We have 0.5%, 0.05, and then z-scores are always 0, 1. So let's get that, and also let's take a look at what other spreadsheet would be useful here. So the spreadsheets are organized either by confidence interval or by hypothesis tests. Let's blow this page up a little. So here I have model confidence intervals with spreadsheets. So these are the spreadsheets that relate to confidence intervals, and down here, these are the spreadsheets that relate to hypothesis tests. And if we go to this page here, we'll see that there's one for mean and one for proportion. We're doing a mean, so we would select this one. And I would have these saved on my computer in a special location, so I don't have to keep going back here, or have it filed away in your Google Drive. Then the next question is, are we doing a Z or a T here? And since we were given the population standard deviation, we would use a Z. And then there's two parts to this spreadsheet, one where we're just given the sample statistics, or we're given the data. Now, we were not given the weights of each dog, so we wouldn't use that lower part. We would use the upper part. And so then you just plug in the information that you were given here. And notice we were given the population standard deviation, so that's appropriate here. With a T interval, you don't have the population standard deviation, you have sample. You don't know the population. So that one's a little bit different. So this is the sheet and tab that you should be using if you wanted to try this sheet, the pre-built one. But I'm using mine here, which is similar. All right, so I got the standard error. Next thing I want is my z-score, and then I'll show how to do this in Statkey too. So my z-score is my norm dot inverse, and I need my alpha over 2 value, followed by, it's a z-score, so the mean of a z-score is always 0, standard deviation is always 1 for z-scores. And it always gives you the negative version. I'm just going to use the positive one. So often I'll sneak back into that formula and squeeze a negative in between to say, give me the opposite, the positive version. Now I'm ready to get the error bound to the mean, which is just the z-score times the standard error. So equals z-score times standard error. So that should be the margin of error here, and the mean would be this right here. So in the boxes, I would say it would be 30 plus or minus 3.6-ish. And so then I also might want to get the lower and upper bounds for my picture to be more complete, even though the question only asks for the mean and the standard deviation. And Statkey gives the lower and upper rather than the standard deviation. So I'll remind you how to get back to those. So this would be the mean minus the error bound, the margin of error, and then the mean plus the margin of error. To do this in Statkey, you need the standard error, which is the standard deviation of the sampling distribution. So I'm going to copy this value, Control C, and open up Statkey to see if we get similar results. Nice thing about having Statkey also is we can double check. So hope Statkey matches what we did on the spreadsheet. Pull that up a little. So in this case, since we don't have data, if we had the data, we could bootstrap it, but we don't have the data. We just have the summary, so we have to use theoretical normal in this case. And then they want to know what is the mean and standard deviation. We could also get the z-score here that I calculated if that inverse normal formula freaks you out. I have a mean of 0, standard deviation of 1 is the default. And then if I put the 99% in the middle, 0.99, then it'll tell me my z-score is 2.576. And notice this is just the mirror image, the negative version, which is what the spreadsheet told me to, right? So double check. There's that 2.576 z-score I'm using. And how does that relate to my picture? I said I was going to draw my line for 99% around here. So the z-score, let's write that down here, was about 2.576, which is between the second and third standard deviation. So actually I drew those lines slightly in the wrong spot. And this line should be more over here-ish, and this one there, right? Because that's 1 standard deviation to the left, 2, 3. The z-score says for 99% in the middle, go to about 2.6-ish for the z-score. And the z-score, remember, just counts standard deviations. And this is our standard deviation for the sampling distribution of means. And I also have more information, right? I actually found the actual weight of dogs that goes in each of these spots, so I can fill that in. But let's get it on Statkey too to confirm that these are the right upper and lower bounds there. So in Statkey, I would have to edit the parameters, put in the correct mean, and our sample had a mean weight of 30, and the sampling distribution was the 7.5 population standard deviation divided by the square of the sample size, which I had to calculate, and that's that about 1.4 that I had. And then go back and reset that 99% confidence interval. And what I should get here are about the same numbers the spreadsheet gave me. So 26.413 should be the lower, and there's my 26.413 there. So Statkey agrees. So I'm just going to write the Statkey value, 26.413, which is how that would round to the nearest thousandth. And the other one is 33.587, which should match. And it does. So the question I had in the email is, how do I get Statkey to do this instead of a spreadsheet? So again, for Statkey to do it, you need to know the mean and the sampling, the standard error, which is the standard deviation of the sampling distribution, which is that square root, the standard deviation of the population divided by the square root of the sampling size. Okay, so let's see, what were those numbers again? About 26.4 and about 33.6. So 33.6-ish, and double check 26.4. So this weight right here is around 26.4, and we have a margin of error. Let's draw that in here too. And again, if you use Statkey, you would have to find the distance between these two and then cut it in half. So just to double check that on my spreadsheet, based on these numbers, if I wanted to find the error bound on the mean, I would find out how far apart they are. Oops, equals parentheses, big minus little, and then divide by 2. So either on a calculator or a spreadsheet, you have to do that. And it says here the margin of error should be about 3.587, and that matches, let's see, error bound right here, 3.587. This problem doesn't involve a p-value because it is a confidence interval, not a hypothesis test. So it's hypothesis tests that we worry about p-values. So here, let's see if we're able to calculate it now. Where'd you go? 3.5. I'm going to go call it about 3.6-ish is my margin of error. So that would be the distance from the center to the edge. Error bound on the mean is about 3.6-ish. This right here is my lower value. It's kind of messy. Let's make it a little cleaner. This is my upper. This 30 right here in the middle is my X bar, right? Confidence level. And the main thing I needed to do this was this calculation up here was the biggest deal. The z-score is a big deal too. Because remember the formula, let's write that down again, just a reminder. For the error bound on a mean, if you know the population standard deviation is z, the appropriate z-score related to the confidence level, times sigma over the square root of n, is where this came from. Okay, so let's see what else. Make sure I got all the questions. Okay, I showed which pre-built spreadsheet, got it. And then I was asked about question number 10 in the review. Okay, let's make sure I got the right one. Yeah, so again, there is no p-value here because it's a confidence interval, but hopefully we'll do a hypothesis test shortly. All right, so let's make sure I got the right number 10 asked about. And I'll enter my answers here for fun. The mean is 30, and I think this was what, 3.587 if I remember right. Woo, I got it right. So anytime you do one of these, watching a video or getting help from me, do it again. You get a slightly different situation. Run through it and see if you can get the correct results. And we are in the review. So let's see. Next page. Is this the number 10? Here we go, that you were asking about, or is it in the other section? The other section, okay. Let's switch over. And the applications right here. I think let's stop.